The first factor that I'd like to discuss with respect to micronutrient availability is soil pH and the concept of the ion charge determining the change or determines the change versus pH. All right, so the charge of the ion determines the change of availability with respect to pH. So in front of you, you have a figure that shows you soil pH on the x-axis. Right? So going from left to right, acidic to alkaline, and the relative availability on the y-axis from low availability on the bottom to high availability at the top. And you'll note that at least for these four elements, zinc and iron, as well as copper and manganese, their availability increases as pH decreases. And that's true. The availability of these four micronutrients in terms of being available for plants increases as soil pH decreases. Now, you'll note that the lines that represent either iron versus zinc, copper, and manganese, they slope differently. And they slope differently because of the charge of these ions that we typically find in our soils. So for example, zinc, copper, and manganese most often in our soils carry a +2 charge. And we know from years of soil chemistry work that as you decrease pH, and if you decrease it by 1 unit, say from pH 8 to pH 7, that the change in availability is a function of the charge of the ion. And it's not expressed on this figure, but the y-axis should be expressed on a log scale in terms of availability. Another way to express this that maybe makes more sense is that because the y-axis should be on a log scale, the change in the availability should be 10 to the power of the charge of the ion. All right, so what does that mean? That means that for every 1 pH unit decrease, zinc, copper, and manganese increase in terms of availability by 10 to the power of the charge of the ion, or 10 to the 2, which is 100. So what this tells you is that for every 1 unit pH decrease, zinc, copper, and manganese increase 100-fold. Right? The opposite could be stated if you increase pH of a soil by 1 pH unit. If you increase pH of a soil by 1 pH unit, the availability of zinc, copper, and manganese decrease 100-fold. Similarly, we can describe how iron acts and interacts when pH changes. And you'll note that the slope of the iron line is different than zinc, copper, and manganese. And the slope of the iron line is steeper. For every 1 pH unit decrease, the increase in availability of iron is 10 to the charge of the iron ion itself, which is +3 in most of our soils. So 10 to the third, and 10 to the third is 1,000. So what occurs with iron is, as pH decreases by 1 pH unit, iron availability increases 10 to the third or 1,000 times. And the exact opposite can be stated when we increase pH, that iron availability for 1 pH unit increase decreases 1,000-fold. Okay. And molybdenum is completely different than these other four ions. If you want to know a little bit about molybdenum, I might as well state it here because it's on the slide. Molybdenum, when it's found in soils, is actually found as molybdate, MoO4. So molybdenum with 4 oxygens. And molybdate actually has a -2 charge. And so it acts differently fact, exactly opposite of zinc, copper, and manganese. So instead of decreasing with a increase in pH, it increases with pH simply because it has a -2 charge. So the focus here is on iron and zinc. Iron decreases or increases 1,000-fold in one direction or the other based on whether or not the pH decreases 1 pH unit or increases 1 pH unit. Zinc changes 100-fold for every 1 unit pH increase or decrease.